Hi everybody, it's Saltash Maths Tutor, and this is the second statistics video aimed at A-level, I guess, or if you just want an introduction into some statistics. This is looking at one of the things that can often cause confusion, and we're going to be talking about unions and intersections. And we're going to be talking about the notation that goes with that and what it precisely means. And this sort of links in with the mutually exclusive and collectively exhausted video that comes before this one on the playlist. Okay, so the first thing we're going to look at is this. There's an A there. There is a symbol, which is actually not N, as in ABC. It's not N, the letter N. It's a symbol, B. And the way that we read that is A intersection B. Now what that means is, or as it can be read, is A and B. Now, being a simpleton, everybody, as I am, I look at that uptown shape there and I see an N sort of in there, or I think of, you know, when you have a burger and chips, it would be a burger un chips. I know I've written A and B there, people, but it's that un thing, un, and that's just the way I understand it and the way I remember it. And I guess it's probably one of the simpler concepts. It is the whole and thing, and is what occurs in, if I have two sets, both of those sets. So an illustration here is that I've got a set A, which contains the numbers 1, 2 and 3, and set B, which contains the numbers 2, 3 and 4. So the intersection is at 2 and is at 3. Now another way that I could view that would be if I had, that's badly drawn, isn't it? There we go, that's better. If I had a Venn diagram and I had A and B, so I've got 1 and 2, actually the 2 doesn't go there, does it? 1, 2 is shared by A and B, as is 3 is shared by A and B, and 4 is exclusive to B. So that means that you can see that this is a, if you like, a graphical or pictorial representation of this is A intersection B. So if you're clever enough to do the looking at the sets thing, that's one way, or you might be equally clever and actually write out a diagram or draw out a diagram. And so the next one is A with this symbol, which isn't a U, everybody, B, and that is spoken as A union B, and the upside down symbol thing means union, but can also be read as or, and I guess there's not a massive amount of rocket science here to see that the U of union looks very much like the symbol note, or the notation, the symbol there. So here's my sets A and B that we had in the previous slide, and one of the things about the OR statement is that if we read it in the context of set A and B here, it's saying that A occurs, or B occurs, or both occur. So I can literally read off from here, and I'm going to go in ascending order. I'm just going to read what's in the sets. So I've got 1, and then I've got a 2, and then I've got a 3, and then I've got a 4, and that would be A union B. Some of you may have seen that I used 2 and 3 twice, didn't I? And that leads to, it's a little bit more involved. It leads to something we're going to discuss in the next slide. So here we go. So here we go. A union B, and in the last slide we looked at the fact that we appeared to, when we were looking at things, we counted some of the numbers twice, which mathematically we know that counting things twice is never a particularly good thing. It's just mathematically it doesn't work. So what I'm going to do is I'm going to draw up a quick Venn diagram, and hopefully this diagram graphically represents these sets here, A and B. Okay. Now what I'm going to do is I'm just going to go through, I'm going to say out loud the definition of A union B, which is A or it's B or it's both A and B. And can you see, you're sort of seeing the problem, I'm hoping, that we've highlighted before, that we seem to count things like the 2 and the 3 in this particular case twice. So here we're going to lead to something which is called the general addition rule, and uses lots of the notation that we have used before. So here we go, and this is a slightly simpler way of looking at it. So instead of putting numbers in, I'm just going to literally label up my Venn diagram as looking at the regions within it. So I'm going to call that X, and that Y, and that Z. And I know that A union B is everything in A, or everything in B, or everything in the intersection. And I'm going to basically pull that out. So because A union B is all of this space here. Okay, so it's all of A plus all of B, and we'll see how that goes. So A is X plus Y plus, well, B is Z plus Y. But I know that the total area, if you like, that space occupied in the set is X, Y and Z. But I've already got 2 Y's in here. How do I get rid of that? Well, the only thing I can do is to minus Y. And I know, we know, that the area here is, that's right, it's A and B. So this bit here is minus A and B. This now turns into the general addition rule, which is this. So let's see, changing colour. Let's change colour to something we haven't had yet, everybody. Let's have this colour, which is the probability of A union B equals probability of A plus the probability of B minus the probability of A and B. Fairly simple, isn't it? But it will come up in some of the questions that you will have in your exercise books, and this generating the general addition rule from basic principles may even come up in your exam. Just one special case, if you like, of this is if I've got the set A, which is contains the numbers 1, 2 and 3, and I've got the second set which contains the elements 4, 5 and 6, then you can see that A and B, the intersection of A and B, doesn't exist. So that means for this particular case, the general addition rule of what is A union B, which is A or B or looking at the intersection of A and B, just becomes, well, let me write out the full addition rule. It's probability, make it probability of A U B, probability of A plus the probability of B minus the probability of A and B. Well, that doesn't exist, does it? So if the events in your sets of numbers or your elements or whatever you're counting, there is no intersection, there's no AND bit to it, this bit doesn't exist. In other words, these are mutually exclusive events, then the general addition rule is shortened. Okay, everybody. In the next video I'm going to go through a question which encompasses all of these things. So you have been listening to and watching Saltash Math Tutor. I hope that that has been of some help to you, and good luck with everything. Study hard, do well.